My first company was I got you have a real
Also, like, I also noticed like a lot of the guys now, and they have to subscribe. Yeah. You do anything. Okay, you do like some free stuff. That's like a couple of requests. Yeah, it's just free stuff. You can't even go higher. I mean, you have to like spend like $5 or $10, and that sounds small, but they have a pretty good tech stack. Something like $100, $200 stuff up. So it's not. I don't feel like it's developer fast. It was though.
Yeah, I mean now everything's like so AI.
We're going to get started, so everyone takes seats.
I like everything like that. I don't think I want to shoot. No. Yeah.
I'm taking it.
I'm not a boss.
I'm taking the money and taking it. We don't all this together. I'm not gonna if I went out and said, yeah, I'm $100. How about I do like
You guys want to get a seat? I'll take a picture.
You guys can move around the chairs. They got the move that to where. Okay, cool. Well, welcome everyone. Great to have you here tonight. So we're trying out a new format because we've been hosting these talks monthly, and something that we heard from our last talk was that people wanted it to be really like hands-on and very technical. And so we're trying out a new format. So we'd love to get your feedback, which is going to be kind of like office hours with Pipcat and Coval. I think we hear a lot of really similar questions across the board about like how to build Pipcat applications as well as how to then eval them with Coval. And so today we're going to go through like some of the hardest problems that we're seeing people struggle with in voice AI and how to solve them with Pipcat and then how to find them with evals on Coval. I'm Brooke, I'm the founder of Coval. So my background is from self-driving. I led our eval info team at Waymo, and my team is responsible for all of our developer tools for launching and running simulations. So now we're building all of those best practices and learnings into our application here at Coval, like how do you build really large-scale, reliable, autonomous systems. I think you guys are all like very familiar with voice, but something that's really interesting is how the parallels between autonomous driving and how you chain together lots of very complex non-deterministic models. So that's the approach we're taking. And great.
Hi, I'm Rhea. I'm the founding engineer at Coval, and I'm going to ask some questions.
Okay, hi, I'm Varun. I've been working with video for the last 20-something years now. Started with hardware, middleware, applications, up the stack, and now out of the stack like this. I used to run a company called Pulsats before joining Daily Digital Observability for voice and video. At Daily, we've been building PipeCAD and I've been working with customers quite vigorously over the last 2 years. My claim to fame is mainly about writing RFCs and standards documents. So if you work with the RFC, you'll probably see my name in some of the RFCs if you implement.
Bird gets it from both directions. He's instrumental to the history of WebRTC and also now just came back from 2 weeks on site with a customer. So I know everybody in this room appreciates that. I'm Quinn. I work at Daily. I'm just a curmudgeonly old network engineer, I think is the right intro for me.
And also possibly the most knowledgeable in voice AI today. I think every time I talk to Quinn, I learn something, literally every single time. And I talk to Quinn a lot, so that's an impressive amount. Cool, I think we actually want to start with something cool, which is that Philip, who's here tonight, he was going to like just give us a high level, like he was telling me right before this how he's using Coval to test his voice AI applications. And so wanted to like kind of have him talk through like to get us rolling of like what problems he's been running into, and then also like how he's using Coval to find those problems, because I think it's going to be representative of the rest of what we talked about today.
All right, so maybe I'll give a little bit of background. So I'm Philippe Szymański. I guess the history of my background is engineering at the beginning, very shortly, then most of my career in product management. I did have a very good chunk of my time in quality assurance in a company that I don't think any of you remember. It's called Mercury Interactive, but essentially they were like the peak of quality assurance in the 2000s when the Y2K was around. So my mindset's a little bit around QA, which is helping a lot with evals, which is essentially, to me, quality assurance. So what I'm working on right now, since about the beginning of the year, is building a voice agent. I did start out initially in automotive because my dad and my brother were in the business. I found that it's actually pretty tricky to build a company without actually having a good set of clients you can approach and work with. And then I met an amazing co-founder who's in healthcare. So I may be a little newer to healthcare, but since I've been to the doctor a few times, I call myself somewhat educated, right? And so now we're building an agent, a voice agent around healthcare. Now, what kind is it? Well, today the big challenge that we see is that you're calling on the phone, maybe in a healthcare practice in an office, and you got to go through a menu a lot of times. They're got to call you back because they're understaffed, and you want to schedule an appointment with a doctor. You want to ask some questions about maybe the different healthcare services they offer. You want to know what locations they have. You know, all these kind of things that you would typically have to wait on the line for quite a bit of time. So the voice agent essentially takes care of all that as the first basically conversation point for somebody calling in. So you dial the number from a regular phone and the voice AI picks up. And then it starts having a conversation, and I have a number of use cases there. So what's interesting is that, you know, my journey goes a lot into prompting, I guess, because we're trying to get the behavior of the agent to the point where it actually does the right things and have enough guardrails. It doesn't say bad things, because in healthcare you don't want to do that. Also, you want to run the whole thing HIPAA compliant, which complicates things as well on top of that. So here what I noticed is when I started using Coval, actually what was a lot of fun is that the first time I ran my first test, I'm probably going to go back to that, is that it immediately found a problem with my voice agent. So that's when I got really excited. It's like, wow, okay, why didn't I think of, you know, testing that or seeing this problem? And basically the main issue that it was is that essentially I'm a human evaluator and I have a certain preconceptions about what the patient is doing. I am asking my client to give me more examples so we can use those potentially as part of simulations. But ultimately, I don't have enough combinations out of the box. And what happened is when we ran the first, or I ran the first simulation of Coval, is that it actually went differently in terms of how it started talking and what it said. And immediately I saw, like, whoa, wait a second. Like my guardrails that I put into my prompt and the behavior of the voice agent didn't actually anticipate that. And then I started realizing that you actually have to put quite a bit of logic into your agent, essentially, to guard against that. So yeah, I would say that literally every other day, I would be like, I have a wow moment of Coval because like, I just didn't expect this to happen. So I started creating this compound test like yesterday, and then spending a lot of time about, okay, I just called in to the office and I want to know what services you provide, and when you open locations, all this kind of Q&A. I actually wanted to drill down into one of the procedures that are being offered and actually make sure it properly talks about it. And then like, yeah, I do actually want to see a doctor, and I'm a new patient, and I'm going to go through the intake process. There's actually a lot of logic, and it's one agent, right? It's not actually multiple agents, which potentially, I'm trying to avoid that. I'm trying to see what the limits are of one agent doing everything. And that's basically where Coval is cool, because every time I'm running it, and I'm trying to create these more sophisticated tests, I'm seeing these weird behaviors. And even things like we're talking about latency, you see this spike over here, that's basically, I'm running right now currently, this one with VAPI, is caching the knowledge base that I'm offering it as part of the drill down into the procedures available. And so the first time it's pulling it up and boom, it's a big one. And what's really interesting is that when I ran a test after that with Coval, it wasn't there. And that's how I discovered that there's some caching. And so anytime you do change anything around your agent, you don't want to just throw it in, cold to the users. You actually want to warm it up in a way. So it's kind of like an IT practice thing. So I'm discovering all these really interesting things, and I just wanted to share that. It's a really great product.
Yeah, I think also something that kind of frames the night is like a lot of the things that you're struggling with is like latency, which I think we're going to talk with Quinn a lot about, like how do you optimize latency or how do you do interruptions. Something else I think this test you were just showing me right before is like how the prompt like wasn't doing exactly what you expected. And like these kind of unexpected ways that your agent is like, it's not necessarily that the LLM was wrong or the voice system was falling over completely, but the like quirks of text, trying to say text out loud. So,
yeah, so this was just from this week. That's why it's fresh in the mind. Basically, a new sequence in Coval that I came up with that's a little more sophisticated. And what happened is when the patient is asking what services are available early on in the call, I wanted to be really crisp and short. Okay, these are like 4 categories of services offered, and then really give the opportunity as the human to say, I want to know more about one of them, and then drill down into it. But what happened is, and literally it was not in my prompt at all. I literally had just four words almost, right? And it elaborated. It actually put it 1, 2, 3, 4, right? See in there the big fat prompt. And then actually went 1, it said what it is, and then it kind of, embellished it with, a sentence of what it's about, which I didn't write at all in my prompt, right? So it kind of made it up, but it's kind of logical, to some extent. And then went to the second one. But my main issue is how long it is. I mean, you're gonna wait 3 minutes to hear what the agent's gonna tell you about these procedures? I mean, you just called in, and you just wanna know if you do the stuff that I need. I don't need to hear, a narrative about it. So that was really cool. And so what I did after that is really interesting. So one of the things that I developed as habits, which Brooke may not like, but I'm learning how to use the platform. But I had to step out for a second because I didn't learn how to use the text-based prompting and evaluations yet, which is not voice. And so I went in and actually did a validation with a LLM kind of direct call. Hey, is it going to actually do this issue there? Which it did. And one of the things I do is I actually copy and paste the things that Coval's agent said. So I use this back and forth exact same thing to see if I replicate it, which I did. And then I started tweaking the prompt. It required about 3 turns to validate it's not there. Then I went back to Coval, actually ran the voice one, and it was done. So I have this really kind of interesting workflow as I'm developing, as I'm learning how to work fast, especially where I can do the fast turns with text, and then their voice is valuable and gives me these additional details and nuances.
super cool. Yeah, we were talking before, and I thought it was a really cool example of like running into these issues actually in production. Cool. Well, thank you so much for sharing, Philip. Awesome quick demo. Okay, well, I think that leads us into come back to us. Is like, I think one of the hot topics of like that everyone said tonight was latency, and like how do you really test for latency within your application, and then also how do you optimize latency. So maybe we can start there. Quinn, if you want to do how to optimize it.
Well, I think you have to have a target, right? Because unless you kind of know what you're aiming for, you don't really know what you're aiming for. And what we often tell people is that you can get down to 800 milliseconds or below, but if you're, starting at a second and a half, at least that's a good starting point, and people are not going to hang up on your bot at that point. Then the second thing is you have to have good monitoring. So there's two ways to monitor latency. One is actually record the waveform on the client side, put it in an audio editor, look at the gaps. That's the ground truth. No, you can't do anything wrong when you're measuring latency that way. Very hard to measure latency programmatically that way though. So if you have a tool like Coval where you can have the latency for each stage of the pipeline plus the voice-to-voice total latency on the server side, then you have something you can repeatably measure. A lot of latency does come down to cost and quality trade-offs. So if you're using the hosted services that almost everybody uses at medium scale, you're gonna deal with whatever the latency of those best services are. We were just talking in the before we came up here in a group about tricks you can do, like always fire inference twice and use the first one that starts coming back, which has really noticeable statistical effects on latency, but obviously doubles or close to doubles your cost. So that might or may not be a good trade-off. You can also self-host some models so that you host them directly within your orchestration process. That's hard to do at small scale cost effectively, but also can cut a couple hundred milliseconds or more off of your total latency. So there's a bunch of things you can sort of think about as cost trade-offs, especially as you scale. You were just on site with a customer and they had a ton of latency issues. What surprised you about debugging their latency?
I think I was talking to some people here as well about this. I think, so one, they were self-hosting PipeCat, which is interesting because you run into a bunch of issues around WebRTC that you may not have known about. So belatedly, after banging our heads over it for 3 or 4 days, we realized that they were on non-compute optimized instances on GCP, or just GPU. They had 16, 30, or whatever CPUs on it. But when they kept telling us that they were using 4 vCPUs, and we were like, it doesn't make sense, something's wrong, let's analyze it. But it was super hard to analyze because it was a big company and they have their own machines to do this. So you couldn't just say, tap on someone's back and say hey, show me what's happening here. So it took us a couple of days to figure that out. So compute instances are the thing that they should have been using. That was one. The other thing which was surprising is how they tested their outbound bot. So an outbound call is when the voice AI calls you. And in that case, the typical thing is the bot doesn't speak. It waits for the other party to, whoever picks up the phone has to say hello first. It can't start speaking before the bot knows who it's speaking to. So their test for this was they would just say hello and then count visibly with fingers how quickly the bot responds to it. And if you do finger counting, everyone has a different method or timing for finger counting. And some people would say it's 3, some people would say 1. And of course, if it's 1.5 seconds, it's neither 1 or 3. It's somewhere longer than 1, but no one knew what the number was. And I was on site and I could see the log, so we would, when they were not running on their GPUs, or not GPUs, the CPUs, the general purpose CPUs, they were running it locally, we could see the logs and we could say, time it there. That was easy. But as soon as they pushed to prod or staging, all hell broke loose because again, we were back to finger counting. And I think when ESSA was trying to get Coval up and running, I think with them, it would be good, we had so many things going awry there that we didn't get Coval up until the last day. Which,
the famous source of truth.
yeah, and then there are 8 people in the room counting and everyone, I was counting and then there's an average of 8 people, which doesn't lead to anything. But it was fun. It was, that, unfortunately, big organizations working in financial industries have a lot of regulations. So basically their office network cannot, you couldn't just at Google and will let you go. So that was one of the things. The other thing is that everything is decrypted in the cloud. And they have a different key, so all your TLS termination is elsewhere, and then you have a different TLS termination to you. The same thing was happening on their Kubernetes as well. That's totally okay if you're doing HTTP calls. You have like 20, 30 milliseconds to the beginning of an HTTP call or TCP call. But doing that on a UDP, which is encrypted, decrypted, 20 milliseconds, small 30-byte packets, it's so painful. And none of this was known to us. So when we flew there, we didn't know any of it. Slowly, we figured out all the intricacies of regulation.
I think there was a question about Twilio latency specifically in the spreadsheet. So, fewer hops is better, servers closer to each other is better. Like Twilio is all AWS US East 1 in the US, but you don't necessarily have inference servers there, so figure out where your inference servers are, where your Twilio servers are, put your servers as close to one or the other of those as possible, do the logs, look at where the latency is coming in if you possibly can. So co-locate your servers or put them close to each other. Try to make sure you eliminate extra hops. So if you're doing Twilio and you don't need SIP interconnect for any feature set, do direct Twilio WebSocket media streams. It's simpler and probably lower latency. We might have some corner cases in mind where that's not true, but that would be my rule of thumb. And only add the extra hops you need with SIP transfers and things if you actually need them.
Yeah, I would also say that I really Quinn has talked a lot about latency budget. So putting all these things together, it's your LLM latency plus your every tool call, every model that you add, you're adding latency and thinking about what that end-to-end budget is. But then implementing tracing. So for example, Link, these work really well with Coval and PipeCat, but there's all sorts of tracing libraries out there. And using these to actually trace every call that you're making, because a lot of times there's really surprising behaviors of caching, like Philip shared, or there's actually a lot more network time than you were expecting. And so I think it's actually good to do both tracing of all the sub calls, and then also so for example with Coval, you can do this with anything. It's when you call, you're going to get the received latency, and you can basically find a diff of that to figure out end-to-end network time, etc.
Anything to add? No. Perfect. Yeah, exactly. Okay, so in a lot of your questions, I heard about what need to have your voice agent be natural, and one of the ways that voice agent can really sound unnatural is if there's a lot of interruptions or the turn taking is bad. So the question that I want to ask is what are you even looking for when you're looking for turn taking, and how do you optimize it?
I'll start with where you think the levers are, and then how you can eval it.
So you have to be able to interrupt quickly, but you also don't want to interrupt when you don't need to. And there's three kinds of spurious interruptions that we see people working on fixing a lot. One is background speech. So if you have, somebody calls your customer support line, they have the radio or the TV on in the background. Human customer support agents are probably pretty good at dealing with that. Most transcription models are not. So you will get interruptions. The best advice we have today is use the CRISP speaker isolation model. It's the best thing we found. It's lightweight on CPU, very, very effective at speaker isolation, very expensive commercial license. But you can work around that in various ways. We have infrastructure for PipeCat called PipeCat Cloud that bundles the CRISP library, and you can at least test it that way, and then decide whether to use it. The second kind of spurious interruption is that you have the user what's called back channeling. So you say, people when they talk, they often give people feedback. They're like, oh yeah, yeah, and that is something. If you're just running a transcription model and interrupting when your voice activity detection fires, you will interrupt when people didn't mean for you to interrupt. So there are various techniques for that. I can screen share some code if you want later.
Yeah.
But it's typically you sort of pick up minimum number of words. But that's a trade-off, right? Because you're waiting to do the interruption until you perceive that there's that certain minimum number of words. The bigger solution for that is for the LLMs or dedicated term detection, term-taking models to be smart enough to detect both back channeling and end of utterance and filter out all that stuff. And that takes us to the term detection. So the traditional approach to term detection is voice activity detection that just looks for pauses of a certain length. That lots of us now are working on better models for that, that are dedicated term detection models or term detection models built into the transcription model or to the big audio understanding LLM itself. I can show a demo of the native audio term detection model too, if you want to.
Yeah. No, you should. You can queue up a demo of the main structure. We're still working on the logistics. This is our first time doing like this live stuff setup. But I'm excited to do more of it. I think so. The way you can do this with Coval is that you actually can like detect interruptions. So interruptions is like the most obvious form of like you interrupted or like taking the wrong turn. But then I think the harder thing is like when your agent like didn't speak when it was supposed to. So like the person said yes, like that is correct, and then your agent is like waiting for them to like continue on the thought because they spoke in incomplete sentences. I think we're still like working on like using these combinations of LLM as a judge. We also have like pause analysis built into our app so that you can like detect when your agent paused for too long. And then I think what Quinn said is like really balancing like running interruption detection plus latency and just trading off these two things. Like I think something we did at Waymo a lot was like it's not necessarily that you have like all green tests. The goal is really to like create aggregate metrics that then you're reviewing these release reports to be able to say like, okay, was this like are those trade-offs worth it in your mind? It's not necessarily that you're looking for like, okay, check your app.
This is a native audio, open source, open data, open training code, smart term detection model, and it can perceive both semantics of what somebody says and audio patterns. At least we think so based on the training results. Nobody really knows how deep learning model actually works. We have English data sets in the current checkpoint with 14 more languages coming next week. Sorry. I will try to share again. One fun thing about a really good term detection model is you can use it as a latency reduction technique too, because you can shorten bad timeout a huge amount and rely on the term detection model much more heavily. So instead of having a 600 or 800 millisecond bad timeout, you have a 100 or 200 millisecond bad timeout, and then let the term detection model run and take a couple hundred milliseconds, and then you have very short term detection if the bad model works the way you hope it will. I fell off the network or something.
Okay, we'll wait for. I know Dustin, you had a question if you want to go for it.
Yeah, I just had a question about that one other type of interruptions. Like we experience sometimes maybe cancellation failures that the agent interrupts themselves. Like he experienced that too. And also all of the times when we catch the interruptions, that's also that you do not do interruptions with the back, right? Like then you would rely on the transcriptions to catch, for example, background speech or like set interruptions maybe.
I think best practices, in my opinion, today are to use both bed and the transcription and use both of those signals to determine whether you want to do an interruption, if you're not using smart term. So you can tweak how you interpret both those signals, like with things like midword. And if you're trying to support multiple transcription models, you have timing issues that are different between models, so you have to do a lot of testing because the models can come in after the bad timeout for the transcription, you have to decide what to do when that happens. But typically, I think you do use both transcription and bad for end of utterance detection and for interruption, which is sort of tweak what the parameters you're using are. Does that make sense?
Yeah.
Let's see how we do that. Can you hear me?
Okay, we'll do a demo afterwards. Oh, that's fine.
UDP is hard.
Yeah, I think it's the cat. It's another one. It is actually.
WebRTC on WebRTC.
So a couple of points you guys mentioned. How much of it is the nature of like maybe solved by voice to voice agents? Because some part of it, like the should the agent speak now is about donation maybe? Or like what you was talking about, it's like figuring out do I interrupt or am I being interrupted is part of the audio model and then immediately respond to that. So how much of this do you think is maybe voice to voice domain?
Quinn is definitely the expert on this, but I think voice to voice gives you a lot more signal, which is cool. So like you're able to do, I think, take in a lot more like inputs. I think again in self-driving, there's constantly this swinging between like doing omni model versus like many models, all like having specific responsibilities, and there's just trade-offs between both. Where obviously like one single model can be better at like a specific task, like detecting turn or detecting intonation or detecting sentiment, etc. But the omni model has more signal.
It seems really clear that the speech input, speech output, audio in, audio out models are the future. Today, their architecture is basically the same as the text mode LLMs, or as those models operating in text mode, so they don't do anything like turn detection today. In fact, they don't even really have data training regimes that are focused on understanding things like intonation at all, which you can tell if you like really push on them and try to understand what they seem to be hearing and not. So that will change, obviously, because the people training the large audio native LLMs are starting to think about this stuff and starting to collect data for it. But right now, if you use the OpenAI Real-Time API or the Gemini Live API, and you use their turn detection, they have a separate bad model and now a semantic model in addition to a bad model in front of their speech-to-speech model, just like we do when we're building this stuff ourselves outside the API boundary.
Because the backchannel thing you mentioned was also very interesting. Somehow it just needs to understand that it's not a interruption, it's a ongoing piece of information.
That's right, and now there's just architecturally no way for those models to do that.
Yeah.
They don't stream bidirectional. The tokens, there's no bidirectional token streaming, but that will happen. And I don't know when it'll happen because it just depends on what the big labs prioritize. But an architecture that does true bidirectional token streaming with multiple modes and tokens is clearly what we need here, right?
I was just going to add that in many of these cases, the speech-to-speech, it doesn't have observability. So when it doesn't do something or does do something, you actually don't know why it did whatever. So going back to the hello example response time, what we saw with the cascade model was it was within 200 milliseconds of the mean that it would respond. But the speech-to-speech was faster most of the time than the average for the cascade. But the long tail delays were like, in the worst case, it was like 8 seconds, and sometimes 3 seconds. Most often 1.3 seconds. So, but when it failed, it didn't tell you why it failed. Which basically means that if you make 100 calls and this happens 5% or 8% of the time, someone's not going to deploy that.
We do benchmarks on all of the TTS providers. We've done benchmarks on some of the real time. We have transcription coming out next week, so stay tuned. And I think looking to do a lot more on real time, but I think something that we've seen is you should be caring a lot about like what the 90th percentile or 99th percentile, depending on your sensitivity of your application. There's similar to infrastructure engineering, there's going to be a lot of similarities where you are you trying to get 6 nines of reliability, or are you just trying to get something that works most of the time? The same is true in voice, where it's what 99th percentile latency can you tolerate, what error rates? And so I think while real time is very promising for most use cases, if you're really trying to push the limits of voice AI, I think where Pipecast or where these frameworks that allow you to have more control allow you to actually have a lot more creative and complex and be able to have a lot more control over the underlying layer. Any other questions?
Is it the other way too? Because we have an issue where we need to wait for a certain amount of time based on the semantics of the conversation. Is that also handled in a bad manufacturing thing, or is that totally outside that box?
So the question is, can you selectively refuse to have the model answer? Or how would you put it?
I guess so, yeah. Ours is teaching use case. So I say, okay, I'll start this problem, and I have to sit down for 30 seconds to do the problem.
Yes.
And it needs to not try and keep the conversation going during that.
Yeah, totally. So are there ways to design a system so that it's flexible about whether and how quickly it responds? And that is definitely something we see in a bunch of different use cases. I think there are two, so people are training models to do selective refusal and to return an empty token or an empty metrics frame or whatever, which I think is promising. I haven't seen an implementation of that yet in any of the models that's ready to use, but I think it's promising. There are two techniques that I think are interesting that I've seen deployed to production. One is to specifically prompt the model for things that you want it to refuse by returning a single node token. And you can iterate pretty well and get to prompts where for a big class of things that the model will hear a user say, it just returns that selective refusal token. And then you figure out what you want to do in your application logic. You set timers or do something else. The other is to use function calling for that. So instead of returning the selective response token, you call a function. And then you return immediately from that function with basically a placeholder piece of information that tells the model sort of what to say or what not to say or whatever. And then you keep that process, so you also then fork a task or a process from that original function call that does some long monitoring thing. And when some criterion happens, and maybe more than once as a stream, you inject things in the context and you trigger more inference. I actually really like that pattern, and I think we should document it more because it's super useful. The sort of immediate async function call return plus long running process that then does some kind of context engineering for you.
Yeah, I think this having these really cool architectures, I think especially if you're making voice AI the core of your company, really thinking outside the box of how can you get order of magnitude better performance on these things. We've heard all sorts of really cool things or especially in regulated industries, something that people do is like have a tool call for a specific sentence that they have to say legally. So that can be like a good way to kind of like ensure that you have that reliability. But I think these like mixing tool calls, mixing like context and heuristics plus LLMs can be really powerful in that sense.
I got the advantage of the mic. So one of the things I observe is when you do a quick demo of a voice agent, and you use like a tiny prompt, you know, the latency is great and everybody loves it, right? And then of course that was me, a few months back. So now I'm building a real thing, right? And so I'm adding a lot more context in there, and the prompt is getting bigger. And I guess the question I have is, how much impact does that have on the latency? Because now I essentially get between 2 and 2.5 seconds according to Coval test. But then to avoid a RAG call, I decided to just shove a bunch of text in. And then I noticed it's like 5 and 6 seconds, and then when the conversation gets to the end, it was like 20 seconds right at the end, and there was no tool calls either. So I think there is something about the size of the prompt that starts to really add latency. I was wondering, is what are the thresholds, and what do you recommend as where you should stop and maybe break up the agent into multiple and create something more sophisticated?
Yeah, I'm curious. Actually, I know Aiden is here. I don't know if he's still here. Okay, never mind. We'll call him out. Huh?
He left.
Oh, okay. They're doing some cool stuff around like breaking up the prompt so that you can inject like pieces of it as it goes along. But I think definitely prompts can add a lot of latency to your application. So we've definitely seen that in our tests.
Although in theory, the automated caching that both OpenAI and Google are doing now shouldn't, force you to do the prompt engineering, but I think in practice you still do. And you have to test a ton, because like breaking up the prompt and compressing the prompt even and sending a smaller prompt may hurt your latency for that turn if the caching was working pretty well for you. But the other thing that the context engineering can do is make the model actually do what you want it to do more reliably. So there's all those trade-offs between like focusing the prompt so that you have accurate tool calls or instruction following, and you might bust the cache and take more latency for that turn, almost like doing a tool call. Is that worth it? It depends on if you have good monitoring, you can test those things in a bunch of runs. I think my rule of thumb today for both OpenAI and Google is if you can keep the context below about 15,000 tokens, you see good latency. As the prompts get much bigger than that, you see much bigger spikes. This was on the list of something Brooke and I talked about last week of like having a really good eval set that shows specifically that, like the prompt size versus latency, and running that longitudinally so that you don't just have one day of data or one application's worth of data, but trying to have this be a part of a generalized long-running metrics suite that everybody can then publish to the web and you see what it's like. We didn't do that yet.
I would also say with really big prompts, a lot of times they'll doesn't even really know how to process them, and so either shortening your prompt if that's not possible, giving it a way to process the information, like thinking what it should think about, and those kind of directions is also really helpful, because then sometimes it will skip over parts of your prompt that aren't necessary because you've already told it that it's not necessary.
So which model are you seeing the long latency with?
I'm using ChatGPT for
I mean, in theory, you should get automatic caching.
yeah, that's what I'm surprised.
Yeah, I think actually something else that we've been doing, this is like both on the latency front, but then also on the workflow following front. So something we see with long prompts is that it can be hard to follow along. Like instruction following becomes worse the longer your prompt is, but the more you want to make it follow your instructions, the more pieces you add to your prompt. And so you're kind of stuck with it's like, do I add yet another thing to my prompt, or does that then like make something else go out the window? So we have this metric that allows you to do workflow evaluation. So you can put in what you expect the workflow to be, and then run a bunch of simulated conversations to see how often it follows along that. And I think this is a really powerful way to be able to show like how much does it stick to. Sorry, this like CAS system. Anyways, you all got a snapshot of it. Basically, like, can you see where it goes off the rails, and then iterate on your prompts to see, like, okay, which one helps you adhere to the instructions most closely. Yeah.
I guess you sort of jumped straight into the product, but like, I was talking to someone else, and we're talking about emails, and we both have basically emails. So how do you, like how do you think through this when you're thinking about, like it sounds from what you were saying, is that you basically model an entire sort of conversation with the type where you're like, okay, give me the options, so then I'm gonna say, tell me more about this, and then I will basically see how it responds. Is that the way we think about it, like sort of sample conversations? And then I guess a follow-up to that is like, how do we evaluate when we don't necessarily know that the conversations that customers will be having, but not for like phone service, which I guess is kind of like structured, and you're like, okay, well, there's only really 5 things you can do, check account files, whatever. But in my use case, for example, we're building an interview, and the conversation could really go anywhere. So it's hard to be like, okay, well, I'm gonna eval all different types of conversations because it's just too broad.
Yeah, so something that we've done is actually allowing you to input, for example, like when you create a test set, then you so if you create a test set, you can actually input a graph that allows you to show like different pathways. So that's helpful for interviewers because you can show like, okay, if I ask you like your work experience and you say I have no work experience, whatever, I have 3 years work experience and that's too little, then it goes down one pathway. It depends on like like what kinds of interviews you're doing. Obviously, like more like software engineering interview is going to be more unstructured. I think that's where like, so when you're actually defining the test sets, you can, for example, here, like you'll have this test case, like your name is blah, 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 and you're going to ask about what sessions are held about voice AI today. And so what you can do there is like just be really detailed in your prompt and say like, these are all the things that you possibly, that you wanted to say, or be less detailed and allow it to kind of wander through. But I don't know if that answers your question, but like basically I think you can play around with like non-determinism to actually generate those conversations.
How much real world data do you want a customer to have to come to you with to get value out of Coval?
Yeah, that's a great point. Like you can start, typically what we see people do is that they'll like build the MVP of their application so that it's like actually having a conversation. And then you can run a series of simulations that are like the kind of base case happy path. And then as you're going through those, you're going to start to see very obvious things. So like the thing that Philip showed where it's like, okay, obviously I don't want to be making a list out loud. That sounds like text. Or like these things that you weren't expecting but you're going to find out. And then once you start sending things to monitoring, or like once you deploy live with customers, you'll start to see examples in production, and then you can go through those and be able to do some like live triage. So we have, for example, my casting is really not working, so I'm just gonna get off here. But basically you can like iterate through all the examples, and then add in live human evals to then find issues and re-simulate them. So I think re-simulating is really helpful for these like more complicated examples. So the answer is no data. I think obviously more data is going to be helpful for recreating like very specific scenarios.
It is a follow-up there, like, just learning, when we're talking about actually implementing this and we have real data, is there a way to sort of like connect Coval with the app so that you can feed the thing, so like we actually have to look at my logs, copy, paste. Like, is that how I'm gonna build the, like, for all of the, like, 100 interviews, like, do that for all of it?
Yeah, so the fun thing is that you can actually do observability with Coval. So every time you have a call, you send it to us, and then you can see it live in monitoring, which I wish my casting is working. But you can see it live in monitoring and see like everything that's happening in production, and then when you find interesting examples, add those test cases that you then re-simulate.
I saw you had a question.
That's the other tab I have open that I could show code for is the you're putting behind the VAD an actual LLM instead of like a native audio sort of specialized term detection model. It works pretty well. We have a bunch of examples of that in the Pipecast examples foundational directory using different LLMs and with starter prompts that you can do evals on. I'm curious what you guys have done in production with this. I think the native audio model is significantly better even than the Gemini audio input version of this, because the native audio term detection model, like the data sets specifically have a bunch of like expand, like you kind of extend the word when you aren't done with the sentence, or you have these intonation changes, and training specifically on that data just seems to make a big difference.
Any more questions?
Yeah, just for like observability and tracing everything, what would be like the optimal stack? We have like a multi-agent setup, something like Langsmith, and then for like how does this fit into the entire like observability and tracing stack? Like, what do you recommend to set up just from the beginning?
Yeah, I think from the beginning, typically we see people use Coval observability just like off the bat because they might not say it. They're just like looking to see what happened in the call like at an aggregate level. But then like LangFuse, for example, you can actually integrate traces from Coval into LangFuse. And so you can see like all of the like subs traces of what's happening. I think we're working on, in general, like coming up with more generalized frameworks around tracing so that you can ingest tracing from lots of different places. And so like for these more complex multi-agents, you'd be able to see like, okay, how long did each step take and how is that contributing to latency, or like where did did you transcribe something wrong and that's what threw everything out off, or is like your prompt in like your multi-agent system throwing something off. So having that like tracing plus Coval, I think is where you can get that like semantic overall understanding, but then the really technical deep dive of what's happening in your system. Doing the add-on integration front, Ray has built an insane amount of integrations with different tracing providers, and she's done an amazing job. Any more questions? I guess one more thing on observability, I think looking through your data is a really valuable thing. I think a lot of times people are like, that's super unscalable, like I don't have time to do that. But actually like just going through Coval or whatever you use to look through all your calls and just like tabbing through each one and being like, was this good or bad and why? And like writing down, like I really like what Hamo Hussein says around like actually doing like, I forget what he calls it, but like writing down like exactly what went well or didn't go well in each call, because then you start to see things like what Philip saw, like, okay, this one was really long, like this one had numbers, or this one like did these things that it suddenly started speaking another language. Like all these things that are like you wouldn't expect to write evals on, but then you can then back into like what metrics you should be writing and like what things you should be looking at aggregate level.
How do you correlate like the evaluations with Net Promoter Score or like outcome from end customers, right? That's the ultimate goal, is like a successful outcome for that customer, or a purchase for your company. But how do you correlate that actual truth versus the evaluations, or with the evaluations?
Yeah, you can write your own metrics to Coval. So you like if you have data in your system, like you can add that as a metric, and then correlate that. Just like you can create your own graphs and be able to show like, okay, when our latency decreases, like that's correlated with Horizon Net Promoter Score. I would also say like there's all sorts of really cool things like the naturalness of voice, or like how quickly you respond. Latency is a big one. Like saying ums or ahs is going to, like disfluency is going to be big. And, like just generally promoting that, or having a better Net Promoter Score. So yeah, that's definitely something you should be doing if you have, or like part completions is something else that we've seen, like that you actually convert.
So it also depends on, I think, what the prompt was supposed to do. So like if you have inbound flows or outbound flows, inbound flows, like I think someone said like, oh, if you're looking for cash balance, like did it give the cash balance, for example? So looking at those outcomes is an important technique. The company that we were helping recently, they had a bunch of prompts. They're a financial services company, so they had a couple of prompts which were like call back after you close the market. They just want to know, and that was a direct NPS score they wanted. So someone closed the market, instead of the real estate agent or calling back, it was the bot calling on behalf and saying like, "Oh, what's your experience?" And it was feeding into the NPS score directly for that.
The AI agent was calling outbound, gathering the net promoter score.
Yeah.
Wow.
So there's a very easy comparison between like, did it do the job and was it good enough, or was the person frustrated with the bot compared to the agent themselves, right? Like, so they had a bunch of these analysis happening, and that's one aspect of it. But the second, why most of these folks want to do outbound is eventually they want to sell some kind of thing, and in those cases it's kind of very obvious. Like you make 10,000 calls to do something, and you don't know how many of those actually got a meeting set up, for example. No one's buying off the phone call anyway, so it's all about like setting up the next meeting, will they talk to a human, all those things come into play there.
It seems like there's almost a split in terms of what emails are important, where it's like there's some like very voice specific emails where it's like, exactly like that kind of stuff. And other ones where it's just, if you have a more complex, but not direct graph use case, just general capability of how to stay within certain bounds or achieve outcome. Would you recommend correlating the emails together, or would you judge them very differently? Like you could just judge the model's ability to do a certain thing, and then also judge the parts of the voice like the. Make sense?
So are you saying that like you basically have these very performance oriented things, which is like can it do the thing that you're trying whatever. Your like performance oriented things around like did it do the thing I wanted it to do like very tactically versus more like kind of like the softer skills versus the like was it fast and it interrupts these types of things.
Yeah, this is much more like looking at voice specific things versus just like general like how is this quality of the thing on the call?
Yeah.
You know?
I would say like generally there's a very few, there's some things like latency is like a very hard metric. I would say a lot of things though in general are going to be like somewhere in between where like for example, like did your agent talk for too long or too little? Like what was the latency before your agent started talking? Some people don't care that much, right? Like if you're trying to get a refund, like your latency of when your agent picks up the phone isn't that bad, but with outbound sales, the latency of when your agent starts talking is super important. And so I would say even though some of these things feel like very hard metrics, a lot of them like there's a lot of context in the conversation that's important. In general, what we see is people using Coval for like conversation level analysis. So like being able to say like, did this thing happen towards the end of a conversation? Or like, what was the conversation as a whole? Did you achieve the objective? Whereas like you might use any of these tracing providers or like Datadog or like existing infrastructure to do things like span analysis, like what were the steps in between.
Yeah, just in general, what are your favorite voice experiences that you've seen shipped to production? Do you guys have any like personal favorites?
I mean, I just have fun building stuff for myself. So like, I like the fact that we can now run local models on like these machines. I'm building a lot of local stuff. I did a demo with Shrestha from Google at the AI Engineer World's Fair that showed like a little chunk of this to-do list thing I talk to every day. I think there's lots of amazing stuff getting shipped to production, but I also think everybody in this room should just be building stuff for themselves and talking to computers all the time, because it's the future and like we're inventing the future. So we should do it for like as personal projects as well as things we're building for our customers.
I think some of my favorites are like industries where there was a very little software penetration. So I'm excited about like logistics and healthcare, like meeting truck drivers where they are, meeting policemen where they are, meeting like finding these opportunities where there's like you can't go in and just say, oh, we're going to create a universal API for this, because like there's a reason why these APIs don't exist. And voice offers this opportunity for a universal API where anyone can talk. Like you can have a human on one end and an autonomous system on the other, and those two things can interact. Whereas like before, you would have to have both like operating in this way that the data is accessible. So like for example, trucking and logistics, I think there's a lot of cases like this where you're doing really complex like negotiation, and also like dispatching, like logistics, integrating with like, drivers where they're already on, like they're not on their computer. So those are pretty cool to me.
Okay, great. Thank you guys so much for coming.
Yeah, and we also really want to be doing more of these. I think like trying to do more like work, like office hours so that you can bring your problems. We're also going to be around after this, so if you have things that you want to talk to us about, like how to set up your Coval evals or how to set up PipeCat well, we're around. So yeah, thanks so much guys. Thanks for coming.
Need help? They actually talk about
Ich hoffe, dass wir Voice to